All right, class, welcome to your last and final example for writing an equation on a scatter plot. Now, I will warn you that this problem does get a little bit hairy, so make sure that you are writing down these notes, pausing the video as we go through so that you can keep up at your own pace. Let's read the question. Mari has an ice rink in his backyard. The scatter plot shows the thickness of the ice relative to the temperature. So let's understand what our graph means. As the thickness increases, my temperature is going down. And that makes sense. As my ice gets thicker, it's getting colder outside to support that ice thickness. Now, again, we can take a look at this and kind of look at our points and understand what's going on. When I am less than 1 inch of ice thickness, the temperature is -1 degrees outside. When we have 2 inches of ice thickness, the temperature is -6 degrees. So as our ice thickness increases, if I can talk, the temperature decreases. So this is a negative association. Now we're going to write an equation in slope-intercept form for the line that is drawn so that we can make predictions about the temperature of our ice when the ice is 1/3 of an inch. So without further ado, let's begin. To write an equation of a line in slope-intercept form, we need to remember the formula. Y equals my slope plus where I begin. So to understand what this means, Y is going to be my temperature in degrees Fahrenheit. X is my ice thickness, and I pull this from my graph. My Y is my temperature. My X is my ice thickness. Okay, so I'm going to start by figuring out where I begin. So what is my B? Where do I begin? Well, at 0 inches of ice, it is 0 degrees Fahrenheit. So I begin at 0 degrees Fahrenheit. That's where my line begins at. So that's going to be my B. Now, I also want to find my slope, and we'll talk about what that means as we go. So to find slope, this is going to be my M. Again, write this down, please, as we go. That will help you remember how to do these steps. My ice thickness, so I'm just going to label this as thickness, and my temperature is going to go on my XY chart. Now, the reason that my ice thickness goes on the left is because that's my x-axis, and the x-axis always goes on the left of my graph. Temperature is my y-axis, so that goes on the right side of my graph. So I'm going to pick 2 points that my line goes through. I'm going to choose my first point of 0, 0, where I began, and I'm going to use the point 1/3, -1. Now, let's take a look at where 1/3, -1 is, which is that second point I used. So if I look at my graph, each tick mark is 1/3, 0, 1/3, 2/3, and 1 is 3/3. Continuing on, 1 and 1/3, 1 and 2/3, and 1 and 3/3, which is 2. So my point that I have picked, which again my line goes through, I want to choose 2 points that my line goes through, is 1/3, -1. 1/3, -1. That's where I got that point. So now I'll find my slope. To get from 0 to -1, I go down 1 degree. To get from 0 to 1/3, I go up 1/3 inch in ice thickness. So remember my slope. My M is my change in Y, which is down 1 degree, over my change in X, which is up 1/3 of an inch. Now, I want to make sure that my denominator is 1 because I want to know how many degrees do I drop when I increase by 1/3 of an inch of ice. So to figure this out, I'm going to divide my numerator and my denominator by 1/3. 1/3 divided by itself is just 1. So my denominator is 1 inch. 1 inch. Now my numerator is -1 divided by 1/3, and I'll just do this out on the side. -1 divided by 1/3. So remember, when I divide with fractions, I keep change flip, so -1 times 3/1, or just 3. So that leaves me with -3 degrees Fahrenheit. So my rate of change, my m, or in other words, my slope, is -3 degrees Fahrenheit per 1 inch of ice. So my temperature drops 3 degrees when I increase by 1 inch of ice. Okay, now to write our equation. So this is going to be the last part of this question until we use our equation to make a prediction. My temperature, y is my temperature, is that I begin at 0 degrees Fahrenheit, and then my temperature drops, or I add negative, or I subtract 3 degrees Fahrenheit per every 1 inch of ice. Remember that X is your ice, Y is your degrees Fahrenheit. Now, I don't have to write 0 when I have an equation. So my final equation is just y equals -3x. I begin at 0 degrees Fahrenheit, and then my temperature drops 3 degrees for every 1 inch of ice. Okay, now let's use our equation. I'm going to erase this, so pause the video if you need to write anything down. So it says use the equation to make a conjecture, where this is part B, about 1/3 inches. So my equation was y, which is my degrees Fahrenheit, equals -3 times however many inches of ice I have. So using my equation, it would be y equals -3 times 1/3. Remember, to multiply fractions, we multiply top, multiply bottom, simplify. This is the same as -3/1. 3 divided by 3 is 1. So my answer is just -1 times 1, which is -1. And that is going to be in degrees Fahrenheit. So my answer, my conjecture, is that when I have 1/3 inch of ice, my temperature is -1 degrees Fahrenheit. Now, I could have confirmed this by looking at my line. However, there are times when you will not be given a trend line on a graph, where you will have to write an equation to make these predictions without looking at your graph and eyeballing it. All right, I hope this lesson was informative to you guys. Thank you for watching. Please start your assignment on the next page in this module, and of course, message me with questions. This type of problem will take time to master, so be patient with yourself. And again, I'm here for you guys, so message me if you have any questions. Take care. See you later.